In this video, we're going to break down the anatomy of an LLM request, and we're going to understand exactly what happens under the hood when you send a message to your favorite LLM provider, for example, Anthropic, OpenAI, or someone else. We are going to look at the lifecycle of how the user sends a very simple message to the LLM, all of its building blocks such as tool, system prompt, messages. We are going to revisit the cache. We're also going to understand what happens when user wants to use skills, and we're also going to break down how exactly tool use works. And basically everything you need to know how an LLM request is constructed. Let's jump straight into the LLM request. The LLM request could be conceptually broken down into those 5 building blocks, although you'll see in reality it's a bit more complicated and they are a bit intertwined. So we have the system prompt first, then we have the definition of the tools that Claude Code has, and I'm giving an example here as Claude Code, but this applies to pretty much any provider or coding agent. Then we have the memory, we have the skills, and we have the conversation history, the chat history between the LLM and the user. And I'll be using Claude Code and user here interchangeably because Claude Code is running on the client. And then we have the Anthropic server, which is actually the LLM or Opus in this case, because we'll be using Opus 4.8. Now, the whole conversation history between Claude Code and Anthropic server is based on those building blocks, but they're not sent as you see them here to the Anthropic server. There is a bit of massaging that Claude Code is doing in order to pick only the most important things to send as part of the context so it doesn't pollute the context window too much. Now, when we type in Claude in the terminal and we open Claude Code, there is a simple message here that is called the Quota probe that appears before we start even talking to the agent. But how do we know that this message exists? Well, I use the proxy, so I put a proxy in front of Claude Code so we can inspect all of its messages. But because Claude Code is closed source, we cannot inspect the source code to understand what exactly happens. But what we can do is put a proxy in front of Claude Code. And that's what I've done in this video in order to inspect every single request. And this was possible because of this open source tool. I want to give a shout out to the guys, claude-tap, amazing tool. I've modified it a bit for this video so it's easier to understand what happens exactly under the hood. When we open Claude Code, even before we write anything, we'll see that there's this turn one message here, and this is a Haiku 4.5 model. Although we started Claude Code with Opus 4.8, there's this one request that it appears here that I didn't send. This one request is called the Quota probe. So Anthropic is using a cheaper model to probe their servers to return the exact quota that is remaining. Like how much usage do we have remaining for the next 5 hours or for the next week? And we'll see a response like this, unified 7-day utilization, 0.17, which means that I have 83% remaining of my quota for the week in this exact moment of time. If we click the turn one and see the full JSON here, we can find the 7-day utilization at 0 right now because Anthropic just reset the rate limits for everyone. But apart from that, not much going on in this request itself. And then on my first actually real request, I sent to Claude Code, reply exactly, let's plan a trip. And then Claude Code replied with, let's plan a trip as requested. That would be turn 2. We'll look exactly what happens in turn 2, but it's a bit overwhelming at first. So I'd like to at least show you what happens first conceptually. So as a user, I sent reply with exactly, let's plan a trip and nothing else. And there was a post request to the post last messages to the Anthropic server. What this post request includes are the tools that Claude Code ships by default. Those are the most important tools, such as the workflow tool. This is the tool that spans dynamic workflows in Claude Code. Then we have the skill tool, super important. The skill tool is used to load skills. And we'll see later in the video how that exactly works. And then there's the tool search, which is used to search deferred tools. And we're going to understand also what deferred tools are and how this exact pattern that Anthropic is using of progressive disclosure is minimizing the context window pollution. So we have the tools loaded, and then we have the system prompt. System prompt, we know this just includes instruction to the coding agents how to behave, alongside information such as where exactly memory is to be found. And then there is messages. The messages include the conversation history, but they include quite a bit more details, especially the first messages. There's this system reminder that Claude Code sneaks into the first message, and it includes the context of the Cloud MD file, of the memory MD file. The memory MD file itself is a reference file to all the memories that we have created for this project. So we don't have to load all the memories at once. We just load memory MD as a reference file. or at least the first 200 lines. And then based on the memory MD file, we can find the different memories that Claude Code has created for this project. And only then the user message follows. But this is not all. Claude Code also injects deferred tools and skills, and we'll look at exactly what this means right now. As I said, we have the first message, and what the first message does is essentially here reply exactly let's plan a trip, and then Anthropic Opus responds with let's plan a trip. But what are these other things besides the message itself? We have the tools. Those are the tools that ship by default, and also I have modified claude-tap to sort them by number of tokens. So we can see that the heaviest tool is actually the workflow tool. And if you don't use the workflow tool, this is the dynamic workflow feature, you can actually disable it in the settings JSON, and this would decrease your context usage. And then there are different tools that are actually super crucial, such as the skill, the read, the tool search, the edit, the write. And those are loaded in the very first message that we sent to Anthropic server, to the LLM, to Opus. And here's the description of each single tool. And it's very cool to inspect them like this because you understand exactly what happens under the hood. There is no magic here. Nothing is hidden. We see exactly what is being sent to the server and what we get back. We have the tool search, fetches full schema definition for deferred tools so they can be called. So what is a deferred tool? Remember, those are tools that are loaded on the initial startup of Claude Code. Those are essential tools. But we have way more tools than that. We have MCP servers, and those are injected into the first user message here under messages in this system block. And you can see cron create, cron delete, cron list, remote trigger, web search, MCP, clouding, cron browser batch, computer. We can see how many deferred tools we have. If we actually were to include those in our initial context window, they'll occupy at least 100K tokens. This is almost half our context window. So that's why Anthropic only sends the name of those tools that are non-essential and then gives the capabilities to Claude Code to load those tools whenever the LLM requests them. And this is done via the tool search tool. And this system prompt that we are reading, it also includes all the skills that we have installed, or at least their definition. But it's only the description. This is not the full skill. And that's why we have here in tools the skill tool to load the full definition of those skills. And in the system reminder, as I said, we inject the memories and the Claude MD agent files. We also inject the user email and the current date. We also notice that on this very first message, on the second turn, we have 0 cache reads and 33,000 tokens cache created. The way that the caching blocks actually work, the first cache block consists of the tools that Claude Code sends. The second caching block consists of the system prompt, and only then the messages come. So there's a bit of hierarchy in the caching structure because things on top, they change the least and they're least likely to bust the cache. LLMs are stateless, which means that whenever Claude Code sends a request to the Anthropic server, the whole chat history is being sent on every turn. We send a huge amount of text to the LLM. We compute the attention score for every single token in order to predict the next token. And on the next turn, we do the same thing again. It's just too much. So instead of doing that, we take this big block and we cache the attention score. So next time when we send the big block to the LLM doesn't have to compute the attention score for every single token. The LLM already has it pre-computed in the cache, and then it can calculate the next token. Now, of course, it's a bit more involved. This whole big chunk of text is split into actually several blocks. Every block is marked by a cache breakpoint, which is essentially a cache boundary. So whenever we send this big request to the LLM, it would take the first block before the first cache breakpoint. It would look at its cache, and if it finds the hash value 1 of this block, it would take the attention scores from the cache, and it would move to the next block before the next cache breakpoint. So then it would look for hash value 2, it would find hash value 2, and then it would move on to hash value 3. And let's say we don't find hash value 3 because this chunk of text has changed, for example, and then the hash value is different, and then we have hash miss. Everything after this block, after hash value 3, would have to be recomputed again. That's why it makes a lot of sense to push cache breakpoints, because if there was no cache breakpoints, we'll have to invalidate the whole request. But now we only need to invalidate everything after hash value 3. And that's why there are breakpoints after tools and after the system prompt and after every message. And I want to show you here as an example in turn 2, we can see that cache breakpoints. We have cache control. Actually, yeah, if we take the whole full JSON request and we paste it here at turn 2, we can see cache control, ephemeral, for time to live is 1 hour, which means that in 1 hour the cache would be evicted. And in the system prompt itself, there are several cache breakpoints as well. And they are all over. There are a lot of cache breakpoints, but I want you to know they exist and roughly how cache is working. The third step, we would like to plan a day trip by using a skill. And I know that the text here is a bit small, but I say use the day trip picker skill to choose one destination for a Saturday day trip from Sofia. Sofia is the capital of Bulgaria, and I would like to use a skill to plan a day trip from Sofia. Now let's see what happens first on a high level, and then we'll look at the exact request. I have told Anthropic I would like to use the date picker skill. Now the LLM would figure out, based on my system prompt and the skill descriptions that we have seen, that I have this day trip picker skill. It's here. The LLM will figure out I have this skill. The LLM would also figure out that it has access to the skill tool. And what does the skill tool do? The skill tool invokes a skill to see the full contents of the skill. So the LLM would actually return back to Claude Code and tell, hey, can you load this skill day trip picker with the following arguments? And it would ask Claude Code to invoke the skill tool for that. And then the Claude Code would invoke the skill tool, would load the contents of the skill, and would tell the LLM, here are the skill contents and here are the arguments. And then the assistant would do some thinking in the background, some planning for the trip. And then it would tell me what destination I should visit and why. This is Plovdiv, this is another city in Bulgaria. We are going to turn 6, which is when we send this message, and we actually see the user message here. Use the day trip picker skill to choose one destination for a Saturday trip from Sofia. The response is a JSON, which basically asks Claude Code to use the day trip picker skill, and then it passes some arguments based on the skill description. If we copy the full JSON of turn 6 here, and then we paste it in cursor, and then we'll look for it, we can see that the exact contents of the request have been type tool use, name skill. So we're going to use the skill via tool use. And we're gonna load the day trip picker skill. Like, there is no magic. Everything is just back and forth responses and coordination between Claude Code and the LLM. And now what happens, what Claude Code is doing, think about it for a second. Claude Code would use the skill tool and would load the contents of the day trip picker skill and would send them back to the LLM. And the contents are: choose exactly one destination using general knowledge only, return exactly destination and why. Now in this turn, the LLM gets the response from the user, from Claude Code, and then does a bit of thinking, and then it answers as requested by the skill destination Plovdiv, and with a reason, about 2 hours from Sofia. It's an old town. And with that, we've wrapped up how skill is being used, how Claude Code and Anthropic servers are coordinating and the user in order to launch and use a skill. But in order to understand the full picture, we need to also understand how tool use actually works. Again, I'll type into Claude Code, search the web for 2 activities at the destination you just selected. So I'd like to find out 2 activities that I can do in this city that Opus suggested. So I'm asking Opus to search the web for activities, and Opus, again, based on our system prompt here, sees that we have web search and web fetch tools, sees that it also has access to the tool search tool, and now it would ask Claude Code to load the full definition of the web search and web fetch tools. The assistant is saying search tools, web search, web fetch, and then the user or Claude Code would return back the definitions of web search and web fetch. This happens on turn 11. We can actually find out by going to turn 11 and then copying again the full request response JSON file, pasting it in cursors, looking for web search, and finding out the exact definition of the web search tool. There's a description, search is the web, and there's an input schema, which is query with description, and then with allowed domains and some other arguments that we can pass to this search tool that the LLM can invoke. And what is happening is that on the next turn, the assistant actually uses this web search tool and searches the web with a query, and then the user returns back the results from this query, and then the assistant finally answers. This is on a high level what happens, but we can also look at the exact response and requests to get a better idea. I know the text is a bit small here. We have asked for 2 activities at the destination, and we can see that the LLM executes web search 2 times, searches the web, finds some links, and then it also executes some fetch for those links, the web fetch, goes back and forth a bit, executes more fetches, and then finally, when it has searched and fetched enough information, delivers an answer. For example, on turn 11, when the user has asked search the web for two activities, the assistant has asked for the full definition of web search and web fetch. The user has responded with this full definition of web search and web fetch. And we can see around turn 14, if we inspect the tools, we should be able to see web fetch and web search here, which means that the LM has loaded them. And we can also see their definition here, web search and web fetch, how to use them. And the assistant has asked the user to execute two web searches with the following queries. Then the user or Claude Code has actually executed those web searches and has returned back the response to the assistant or to the LLM. We have a cache breakpoint here, and then the LLM has responded back with search results are mostly third-party aggregators. Let me fetch the museum's own sites. And then the LLM asks again Claude Code or the user to use web fetch tool this time with the URL and prompt. And you can guess what happens on the next turns. The user answers the LM with the results from those fetches. And then the assistant looks at those final results, summarizes them, massages them a bit. And finally, as we said on turn 23, the LLM responds, both verified from the venue's own sites, not aggregators, and then it responds with the full suggestion. Again, the full flow summarized is that user asks the LM for something. The LM recognizes that it needs a tool. It asks the user for the full definition of this tool. The user responds for the full definition. Then the LM now knows how to use the tool. The LM asks the user to use this tool. The user uses the tool, passes back the response to the LM. The LM does its crunching and thinking, returns a few more times requests for tool use, and after it has gathered enough information from Claude Code or from the user, it summarizes this information and answers back finally. And the final response is, as we have seen, both verified from the venue's own sites, not aggregators. And we can see that the cache breakpoints are doing their job. We have a lot of cache reads, we have some cache writes, and we have a lot of cache hits. Now I'm going to go very, very quickly through the last two examples, which include MCP tool use and memories, but the pattern is pretty much exactly the same. I'm asking the LM to create a Gmail draft at this point. And you notice that on every single turn, I need to scroll again through the exact same history that is getting longer and longer. This is what we are talking about, that the LMs are stateless. Let's see the back and forth conversations for the last two cases. Again, I'm saying create an unsent Gmail draft with no recipients. I've confused the LM a bit here because I said later as recipient use my email. And then the LM recognized this confusion and told me your message asks for two incompatible things. And then the LM asked Claude Code to use the ask user question tool to ask me the question, would you like no recipients or would you like recipient after all? And then the result of this tool is sent to the LM. And now the LM recognizes that it needs to create a Gmail draft. In our system prompt, the LM finds that there's a deferred tool with name MCP Claude AI Gmail create draft, which I can actually show you. It should be somewhere here. It's actually here. So the LM has found this tool and has invoked tool search with the name of this tool in order to get again the full definition of the Gmail create draft tool. Claude Code has responded. The LM has loaded the full definition of the tool in its context. And in the next step, Opus, the LM asks Claude Code to invoke the create draft tool with the following arguments. The tool is invoked, the draft is created, and the assistant answers with the draft created. And we can see here the answer, draft created. Now I'm asking for the last thing, how we use memory here. Remember, the trip planning code name is Cobalt Picnic, save it into a persistent memory. Again, in the system prompt, we have explained to the LM how memory exactly works. And the LM understands that it needs to use the bash command to list all the memories in this specific project. List existing memory files, and the result is no such file or directory. And the LM figures out the memory directory doesn't exist yet, so the write will create it. So it calls another tool, the write tool, which was part of those default tools that Claude Code ships with, and then it writes some memory. The file is created successfully. We can see here, wrote two memories. We can click it. We can see all the memories that have been written. And then the code name is saved into the memory MD file, and the LM responds with saved. The code name is remembered, and now we have persistent memory as well. I hope this video was helpful and demystifies a bit the anatomy of the LLM request. It's not magic, it's just code with a bit of intelligence from the LLM and some smart engineering from Anthropic to not pollute the context window. With that, thanks a lot for watching and see you next time.